In this lesson, we're going to look at how to use algebra to solve problems that involve congruent figures. So when we know if two figures are congruent, we know that all of their corresponding parts are also congruent. So all of their corresponding sides and all of their corresponding angles must be congruent if the two figures are congruent themselves. So if we have this situation here where it says we have triangle ABC congruent to A prime, B prime, C prime, that means that angle A has to be congruent to angle A prime, B and B prime, and then C and C prime all have to be congruent. So right away, I know that angle C and C prime, these two angles, must be equal to each other because they're corresponding angles in congruent triangles. We can also sketch a picture, which I'm going to recommend doing anyways, even if you make the connection right from the description, just because it's nice to have a visual. So if I sketch a picture here, again, it can be any two triangles that look congruent, and you want to put your corresponding parts in the same position. So A prime, B prime, C prime should match up with A, B, and C. And then if I label what was given to me, so I have C is 4x minus 30, and the measure of angle C prime is x plus 15. And they also give me the measure of angle A, which is 2x plus 35. Again, right away, I know that these two angles, C and C prime, must be congruent to each other because they are corresponding angles in congruent triangles. They're in the same position. They match up. So that means I can set those equal to each other. So I can say angle C is congruent to angle C prime. Therefore, 4x minus 30 must be equal to x plus 15. This will allow me to solve for x, which is my first step. And then once I know x, well, then I can plug back in and find the measures of the remaining angles. So go ahead and solve this. So if we bring the 30 over and then subtract x, we end up with 3x equaling to 45. Divide both sides by 3. We get x equals 15. So there's our x value. We're not done because it says to find the remaining angle measures. So now what we have to do is we're going to plug this 15 back in so that we can get C and C prime, and actually check it, plug it in, and make sure that you get the same thing. So the measure of angle C is 4 times 15 minus 30. So that's going to give me 30 degrees, which means that the measure of angle C prime, I should get the same thing, but let's just double check. I'm going to go ahead and label that 30 over there. So let's just double check if we plug into C prime. So 15 plus 15 is going to give me 30. So that's good. That's my check that my equation was actually, or my answer for my equation was correct. And then if I want to find angle A, well, they give me angle A in terms of x, so I can plug into that. So 2 times 15 plus 35. So that's going to give me 65. So then from there, if I want to find A prime, remember I know that those have to be congruent because those are in the same position. So that means A prime is going to be 65. So the measure of A prime is 65. You don't have to show any substitution. That's just because those are corresponding angles that belong to congruent triangles. So those must be congruent. And then lastly, we know that B and B prime are going to have to be congruent, but I don't know either of those. So think about how we could solve that. So in a triangle, if you know 2 out of 3 angles, you can always find the third because in a triangle, all angles add up to 180. So in order to find angle B, what I'm going to do is 180 minus the 30 degrees minus the 65 degrees, and that's going to give me 85. So that's how I find angle B. And then once we know angle B, well, B prime has to be equal to that. It has to be 85. And you could check it again and say 180 minus the two angles, A prime and C prime, it's going to give you 85 as well. So that's how we find our missing angles. For this problem, we aren't able to find the sides because I don't have any expressions on those. So for this, it's just find the angles and that's it. So let's look at one more example where we find the unknown sides. So in this picture, we have two triangles that are congruent, and we want to find the variable, so we want to solve for a, and then we're going to find the lengths of all four sides. So when we look at this, the first thing is, let's go ahead and highlight the two triangles that they give us so we know what we're talking about and which ones we're looking at. So ADB, so triangle ADB, and then triangle B or CBD, so CB and then D. And I want to look at, well, which sides correspond here. So if I look at BC, so if I look at BC, the first two letters over here are CB, that has to match up with AD. And it's marked in the picture, but even if it weren't marked that these are the two congruent sides, I can look at my congruent statement and know that those two match up. So I know that AD is congruent to CB. So then from there, set them equal. So AD is A plus 60. Well, that must equal the length of side CB, which is going to be 6A plus 20. And from here, once I have an equation set up between my expressions, well, now I can solve for A, and then once you know A, you can plug it back in. So let's go ahead and solve this. Subtract A from both sides, move this 20 over to the other side. So we have 40 equals 5A. Divide by 5, we get 8 for A. So there's the first part, the value of A. Now it says that we want to find the lengths of the four sides of the quadrilateral. So notice it's not saying the sides of the triangles, but the sides of the quadrilateral. And for this quadrilateral is actually a parallelogram. There's enough properties because I have congruent alternate interior angles, which are making these lines parallel and congruent. So I'm actually going to switch this and say of the parallelogram. And the reason why I need to know that is because a parallelogram opposite sides are congruent. So that would mean that these two sides are going to end up being the same value. So because those are the same value, that's going to allow me to find all four sides of the quadrilateral. So we're looking for the sides of the quadrilateral, not the sides of the triangle, because there's no way for me to find BD since there's no expression on there. So in order to find our sides here, let's just go ahead and plug our 8 back in. So 6 times 8 plus 20, that's going to give me BC. So BC is going to equal 68. So there's one of the measurements, which means I'm going to go right down to AD and make sure that I get 68 for that. That's a good check to make sure that we solve correctly. So if I plug in 8 plus 60, well, that's good. I get AD equals 68. So there's another measurement. And then over here for AB, now that I know A, you can plug in. So 5 times 8 minus 12. So that's going to give me 28. And then there's no way for me to check CD other than to know that the opposite sides have to be congruent in this parallelogram. So that means CD is 28. So there's our four sides. So again, the main thing you have to get out of this lesson is if you have congruent triangles, identify their congruent corresponding parts, and then set those expressions equal. So any sides that are corresponding that belong to congruent triangles or any angles that are corresponding that belong to congruent triangles must be congruent. So you can go ahead, set up an equation, solve for the variable, and then find all of the other unknowns from there. So go ahead and complete the check your understanding page and write down any key ideas that you have from this lesson.